Uh, in this session, I plan to take you through the various roles that you'll come across in data science and how do you prepare yourselves to get into those roles. But before that, let me introduce myself to you. I have little more than 30 years of experience. I started my career, the professional journey started in market research way back in I think 86 or 87. I was a market research executive. My responsibility was to analyze the data set coming from the fields and share the findings with the customers. Subsequently, I switched into IT, where I came into a company called NIIT, where I was a database administrator in Sybase. And I used to work on associated products such as Power Builder. And also I worked on Oracle along with Power Designer. After spending a few years in the technical role as an admin, I came to Bangalore, where I got an opportunity to work with a company called Wipro, who sent me to their customer location in US, New Jersey, Dun and Bradstreet, where I learned to work with large data sets on mainframe and other environments. Subsequently, I moved out of the conventional IT and came into big data technologies. This was around in 2012. At the time, big data was becoming very hot. There was a lot of demand for professionals in that area, so I jumped into big data. I spent around 6 months preparing to get into the big data technologies, and subsequently I jumped into it. I realized that it would be more apt for me to get into data science rather than big data, because I already have worked on the various data analytics methodologies. So I came into data science in around 2014, and since then, there's no looking back. I'm in this area, sharing my knowledge and experience with people. This session, I would like to begin by first talking to you about what exactly is data science. I was told that many of the people who are going to log in today, these people are people who are just starting their professional life, maybe 0 to 2 years of experience. Of course, there are some who have much richer experience. They are also logged in. I hope the session will address, in a way, the requirements of both these kinds of people. So let me start by discussing with you what data science exactly is. I'll use a very simple example. I'll not go into the details of it. Then subsequently, I'll show you that any data science project is a set of steps that you need to execute. And when we understand those steps, I'll also stress on that how at every step or every stage of the data science project, you need certain special skills. And in the process, I hope I'm able to convince that data science is a team effort. Data science is not one single data scientist heroic effort. Data science projects, they rest on the shoulder of various kinds of experts to become successful. So data science is a team effort. Many experts bring in the expertise to make the project successful. Many people aspire to become data scientists. Many youngsters today, they connect to me on LinkedIn, they connect to me during my sessions face-to-face. They all show a lot of keen interest in becoming data scientists. You can become a data scientist. Why not? Definitely anybody can become a data scientist. Why not? But before you get into that role, it's very important for us to explore what are the other roles available. And take a decision whether one needs to get into this role, or are there other roles where they can flourish even more. So in this session, my whole objective conducting this session is to help you understand what are the different kinds of roles, what are the demands placed on these roles, what kind of skills are required to get into these roles, how you can prepare yourselves to get into these roles, and if you want to become a data scientist, why not? You can. So how do you prepare for it? So with that objective, I'm going to set the ball rolling. So I'll start by discussing with you what data science is in the first place. In a very in a very crisp way, one can define data science as the science of extracting hidden information from the data sets. Now, I have used three keywords here: science, hidden information, and data set. The science which we are talking about here is not physics and chemistry. The science that we are talking about here refers to the maths and the statistics. And before too long, it's very important for me to tell you that to get into data science, you don't necessarily have to be a PhD in maths or MS in stats. I'm not. Even college level algebra, the first year, second year, whatever you do in college level, is sufficient for you to get into this role. I personally believe that there are two types of data scientists in the world outside. One is operational level data scientists. I come from that group whose main objective is to extract actionable insights from the data. There is another class of data scientists who not only work on extracting actionable insights from the data, but they also get involved in developing new algorithms or fine-tuning existing algorithms, so on and so forth. Those people need to be exposed to very deep mathematics, and those people generally are PhDs and MS in mathematics and statistics. So at operational level, where I come from, I am not a PhD in maths or MS in stats. I know sufficient mathematics that enables me to do whatever I do. So the science part behind us, what do you mean by hidden information? Hidden information means some kind of information that is there in the data set, but it is not apparent, it is not obvious, it is not visible, given the format in which the data comes to you. I'll give a very concrete example of this in a few seconds. That information, if you're able to extract, can be leveraged upon subsequently to build very good, very high performing models, which will give you good results when you put those models in production. That brings me to the third one, that is the data. When we work on these projects and build models, data is not often available to us on a platter. Given the problem statement, we have to go and find out what kind of data we need, where the data is, how do we get it, all those challenges come into play. So I'll talk about these things again in detail down the line. So the word hidden information here means some kind of actionable insights that can be extracted from the data. That is very important skill. Now, you may ask the question, what is a model and why do we need it in the first place? All models that we build, they represent certain processes in the real world. The processes could be tangible, intangible process. The process could be simple or complex. If we build a model to predict the miles per gallon of a car, given the characteristics of the car, such as the weight, the horsepower, the acceleration, so on and so forth, then we are trying to mimic the behavior of a car through a model. And the model is trying to predict what miles per gallon this car is going to give, provided the characteristics of the car. Such models are tangible models because they represent, such models represent tangible process. And this model is not a very complex model. On the other hand, if you build a model to represent the behavior of customers, I want to know which customers are going to churn and which customers are going to stay. Then I want to mimic the behavior of the customers and represent it as a model. This model is an example of a complex, intangible process. So when you look at it, all models, they map to certain processes in the real world. Those processes could be tangible, intangible, simple, complex. That brings us to the next question. Why do we need such models? We need models to be able to predict the future behavior of these processes. If using the customer behavior model, if I'm able to predict the behavior of the customer down the line, if I modify the price of the commodities, what kind of behavior can I expect from this customer? Of course, we don't build models for individual customers. We build models for groups of customers who have similar characteristics. Or what will be the impact of an advertisement strategy on the customers? How will they react? If I'm able to predict that accurately, then you can understand how helpful it will be to my business. So we built models to predict the future behavior of the processes that those models represent. The more correctly a model mimics the behavior of a process, the more accurate the model is likely to be. The more accurate the model is, the better the job I can get done. And to create such accurate models, it's very important for us to be able to extract over and above the given information, any hidden information in the data set. And that is exactly what data science is. I used to do similar activities way back in the 1986 when I was in market research working for a company called IMRB. I have made use of all these techniques such as decision tree, clustering, naive Bayes algorithms, and all these things to behavior models. Now, what is the difference between what we do today and what we used to do so many years ago? So many years ago, I'm talking the 86, we didn't have, though we did analysis of the data sets, we did something similar to what we're doing today. We didn't have at our disposal so much of information that we have today. The information used to come from the field in form of questionnaires, which used to be converted to CSV files. Whereas today we have data which we can take from websites, we can take data from NoSQL storage systems, we can take data from Hadoop systems, we can take data from mobile systems. Data comes in so many different formats in so many different ways. And the volume of the data that we have today at our disposal to work on, that is pretty huge. I remember doing these market research projects where the number of data points I used to work on would be just a few thousands, maybe 15,000, 20,000. And using those few data points, I used to try to understand, say, for example, the behavior of the customer. At the time, I was working in a place called Delhi, which is the capital of India. The population of Delhi at the time was 1 million plus. And here you are using 30,000 data points trying to predict the behavior of a million plus population. In today's environment, we have access to technology, we have access to data sets, and the combination of these two is what has made data science so enriching, so powerful, and that is what has made data science so very popular today. Right? So let's go ahead and explore this further. In this example, I'm going to take a data set which is available at UCI. I've given the URL here. This URL gives you a lot of open source data sets. So I would request all of you who are interested in data science to note down this URL and go through this URL when time permits. The data set which I have taken is called CAR MPG dataset. And I've given you a sample of the data set over here. In this data set, the sample which you see on the screen, we have a column called MPG, miles per gallon, and we have the various characteristics of the car name, the car type being manual or automatic. Manual means 0, automatic means 1. Origin of the car, whether the car was manufactured in the America or the Europe or the Asia, and so on and so forth. The objective of this dataset and the associated project is build a model which will help you to predict the miles per gallon of the car given the characteristics of the car. So this is a second-hand car sales dataset. Imagine you're working for second-hand car sales retailer and you are a data scientist there, you have to build a model. The reason I have taken this dataset is many of you would be familiar with automobiles. We have some kind of a domain expertise there. We have driven cars and two-wheelers. And also, some of you probably have already seen this data set and built a linear regression model on this. So let me demonstrate to you how you can, using appropriate techniques, extract from this data set hidden information which is not visible given the data set that we have in front of us. The data in its existing form gives us a lot of information, that the relationship between miles per gallon and the number of cylinders in the car, shown by this graph, the scatter plot here, this relationship is negative. As the number of cylinders increases, the miles per gallon range comes down. This is the weight of the car. As the weight of the car increases, the miles per gallon comes down. We see a negative relationship. We also see outliers, so on and so forth. So the data gives a lot of rich information. However, there is something that this data does not tell you. It's not obvious. When you use the appropriate techniques, what we call the unsupervised learning methods, in which I make use of one particular technique called clustering. Clustering throws out a very vital information here. It shows that this data, internally, it has some logical groupings, clusters of data points, which means data points which are similar to each other, but there are data points which are dissimilar as well. So that analysis shows us that there are some kind of clusters hidden in the data set. We don't know what those clusters are about. We don't know why those clusters exist. We can actually go and explore all these things. We do that. And when you do that analysis on this data set, it clearly shows out that the three clusters are very distinct from each other. So the clusters I'm representing here as box plots. Each box plot, this is called box plot. Within a box plot, you see each box represents a group of records, a group of data points. So when you analyze these groups on a particular attribute such as MPG, miles per gallon, what quickly comes out, what jumps out at us is the three logical groups in the data set. They're very distinct from each other. They're very different from each other. Look at this first one. Look at the first case. In this first case, all those data points which belong to this box or this cluster, they're very low in mileage. All those data points which belong to this cluster, that is those cars which belong to this cluster, they seem to be very high on the mileage. The dashed line you see here, that is called the central value. This is also known as the median. It's very high in mileage. And there are a bunch of cars which are neither too high in mileage nor too low. They're somewhere in between. When I do the similar analysis on the other attribute, displacement, this is displacement of the piston in the cylinders of the car engine. The first group of records representative of the first box, they seem to be having a very high value for displacement. The second box representing the other group of cars seem to be very low in displacement. The third one is somewhere in between. Same way, when you look at horsepower, the first set of cars seem to have a very high horsepower value. The second cluster or second group of cars seem to have a very low horsepower value. Now, when I combine all these three points, what comes out is, using your domain expertise, what you can make out is the first box, it probably represents the large cars. Large cars, trucks, such as Toyota SUVs, for example, they have very low mileage, they have very high displacement, and they're very high horsepower cars. The second box represents small cars, the hatchbacks. They're very high in mileage. They're very small in displacement. The displacement of the pistons is not so large. And they're also very low in horsepower. The horsepower is very low. So what comes out of this analysis is, in this data set given to us, there are three types of cars, or three groups of car, or three segments of cars: the small car, the sedans, and the large car. Now, the question that you need to ask yourselves when you look at this kind of analysis, are the characteristics of these three segments of cars similar? If the characteristics of these three segments of cars is not similar, then does it make sense to build one single model to represent all the cars together? Or should I build separate models to predict miles per gallon for small car, to predict miles per gallon for sedan, and for large cars? So using an information which is not very apparent, not obvious in the data set, but I was able to extract that information using techniques such as clustering, I can formulate my strategies on what my approach should be when I build my models to predict miles per gallon. So this is a very simplistic example of what data science means. Data science is the science of extracting useful, actionable insights from your data and using that insight further down the road to build your models. And what are models? Models are basically a representation of processes in the real world. With that understanding of data science, I would like to now show you what are the different stages in which we do any project. When we do any project on data science, what are the different stages that we go through? Before we do that, one very important point, your ability to extract hidden information from the data set where the hidden information is not obvious is one of the key factors for success in your data science projects. The other factor being your ability to discard useless information in the data set. So you need to learn both the skills to really come out with very effective models. I think I have some questions, kind of let me know. There is a question from Alex. He wants to know, wondering how can I start in data science and ML? What are the areas I should focus on my studies and training on? Alex, just hold on for a minute. We are going to go there. You'll very soon see how you need to approach the data science field. Jayant has asked a question. What are the prerequisites for data science? Jayant, once again, I'll request you to just hold on. We'll come to that part as well. Then Samarendra has asked, when should we apply Python, C++, ASM? Samendra, I'll again take this question in a while. Just hold on for a minute. I'll just take this question in a while. So I'm going to park these questions here. I think I have some more questions. Prachi has asked a question. Churning model used in telecom industry. How many people churn in a month? Prachi, yes, one of the most prevalent applications of churning models, customer churn, is done by these telecom giants, telecom industries, yes, because they actually do business on wafer thin margins. So it's very important for them to keep an eye on their customers, especially customers who are cash cows. Customers who give you a lot of business very frequently, they're called cash cows. Now, I don't want my cash cows to leave me. So customer churn model in telecom is a very important modeling. Yes, definitely. Vijay Reddy has asked, where is the URL for data sharing in the video? Okay, Vijay, probably I did not point this out properly. There is a URL here. It's on this slide. What is data science? In that, I've given you a URL which connects you to a UCI, University of California, Irvine. They maintain data sets for machine learning. There are, to my knowledge, more than 700 plus data sets. So you can go and play around with these data sets. All right, with these questions, some of the questions are parked, which I'll answer in a moment. Let's move on and let's look at the different stages that any data science project will go through. Given the problem statement, given the business problem, usually the business problem given to us is not very well defined. It's kind of a slightly vague. So we have to map the business problems into technical requirements. It's almost a common exercise that we need to do that. For instance, your customer may say, okay, now that you know data science, you're a data scientist, can you help me improve my technical support team's customer CSAT rating, customer satisfaction rating by say 5%? So when such queries come, where the queries come exactly in a business format, we need to convert them into technical queries. And then what kind of data do we need? That's the first thing that we try to understand. Given the problem statement, what kind of data do we need? Once I know what kind of data I need, where will I get the data? Will I get the data from within the organization or outside the organization? And if it's within the organization and or outside the organization, how do I get the data into my systems? What do I need to do to get the data into my systems? So all those things is what we cover in the first stage called collect data. It's at least in my case, it has never been so that you are given a problem statement and the data is readily available to you on hand. It's never been so. It's never been that way. Once I get the data, then comes the next stage called, very important stage called exploratory data analytics. And you make or break your project at this stage. That is the importance of exploratory data analytics. In this stage, we first thing that we do is establish the reliability of the data set. Is the data set reliable? Can I go ahead and build a model on this? For instance, if today you sit down and build a model to predict customer behavior, and somebody gives you data, which is say 3 months old or 4 months old, then I think you are taking a risk. Because of the situation that is prevalent today, the behavior of customer has completely changed. So data that you have captured 3 months ago no more represents the behavior of the customer today. So the reliability of the data is a question mark. So we establish reliability of the data before we start building our models. We explore the data, try to look for hidden information using those techniques. And we also do what is called descriptive statistics. It tells you about the distribution of the data. Basic statistics, such as the central values, the spread, the shape of the distribution. We look at whether there are any outliers, so on and so forth. Once we have done this and established the reliability of the data, then comes the next stage of transformation. Data is never in a state where it can be used for modeling. The data has to be transformed from the state it is in to the state it is required to be in to become useful for modeling. And that's exactly what we do in transformation stage, where we address data-related, quality-related challenges such as outliers, missing values, so on and so forth. We also generate additional features. Given the features, given the columns in the data, that may not be sufficient. We might want to generate additional features from the existing data itself. So feature generation, feature engineering, feature selection, all these things come into play at this stage where we transform data. Once the data has reached a state where we can go ahead and build models using the data, that's where we apply the various algorithms that come into play. If I'm building a model for regression, should I use simple linear regression? Should I use quadratic regression? Should I use decision tree regressor or support vector regressor? All those things are decided at this point where we create the models. So at this point, we do model creation, we do model comparison, we do model testing. All these things happen over here. And sometimes, in some cases, we also put a group of models together into one single unit that is called the ensemble techniques. Ensemble is a French word. I believe it means a group of. So once we have our models ready, these models have been prepared in a controlled environment, in your environment. And in this controlled environment, I want to make sure that the models perform well. And at the same time, the models are generalizable. What it means is the model should give me good results, good predictions. But at the same time, I should make sure that the models will give me similar results when I put it to production. One of the mistakes that beginners often do is they build a very highly accurate model in their controlled environment. But when they take that model into the untested waters, that is the production environment, when the rubber meets the road, that's where the model comes across data sets, data points, which it has not seen in the training set, in the sample data given to us. The model's performance bombs. So how do you prevent a model from failing into production? That concept is called generalization. So we take care of all those things at this point. We sometimes we don't get the minimum required performance from the model. So we may have to tweak certain parameters. We call them hyperparameters. That's what we do here. Once again, when we're doing this, we keep an eye on the generalizability of the model. The model should be able to perform equally well in production. So we keep an eye on those things while we tune the models. And finally, the last stage is deployment of the models. Models can be deployed in various ways. They can be converted to exe files. They can be run as web services. They can run in batch process mode. They can run in a real-time mode. They can be deployed in various ways. In this stage, the data science team, especially the data scientist, he has to collaborate and work with other stakeholders, other process owners in the business, because those people would be very keen on understanding what performance this model is likely to give. Because now you're adding a new component to those processes. There'll be some ripple effect on those processes. So before you get into process change, which is a headache, which is a very cumbersome exercise, can become cumbersome, it's very important to strategize your approach to deploying the models in production. And of course, we have to have a rollback plan in case the model does not work. We need to roll it back. All these things come in the last stage of deployment. And subsequently, we keep an eye on this model in production. It's not that you deploy it today and forget it forever. We keep an eye on this model and we observe it and try to check whether the model is performing as per expectation over a period of time in production. Sometimes we also do recalibration. All models, they need recalibration over a period of time. They're not for life. So that's why it's very important to keep an eye on the deployment stage and subsequently. Now, the reason why I showed you these different stages is, and by the way, before I move on, model building is not a simple waterfall. It's not a linear. What you see here is a directed acyclic graph, which starts from the left and goes to the right. Model building is usually iterations inside iterations. They're loops inside loops. From one particular stage, say tuning of models, I might have to go back to the very first stage of collecting the data. Probably I realized later on that the data I have is not sufficient. The quality of the attributes I have is not good enough to get me the results. I might have to go back to stage one. So model building is an iterative exercise. You will have many iterations in this, but what I've shown here is a simple acyclic directed graph from left to right. This is only at a very high level. So it's always an iterative exercise. The reason why I showed you this, the reason why I'm taking through these different stages is, at every stage of the model building exercise, you need certain kind of experts with certain kind of skills. For example, if you're doing data collection and data is coming from various sources within and outside your organization, you might need people who are expertise in ETL tools. You might need people who have expertise in streaming tools such as Kafka or Flume. You might need people with knowledge of Hadoop to create your data lakes there. When you come to exploratory data analytics, you obviously need people who know some amount of statistics and some kind of mathematics. When it comes to transformation of the data, addressing missing outliers and so on and so forth, once again, statistics comes into play here. Domain expertise are required here, because when you generate new features from existing features, do the new features make sense? Domain expertise will be called into play. When you create models, you need people who have expertise in the various algorithms that are used to build the models. Same way, when you come to tuning of the models, you again need expertise in various algorithms using which you have built the models. Deployment of the model, you need process engineers, people who have knowledge of the different processes. So at every stage of the model building exercise, you'll need experts with certain skills, and hence model building is never a single person's responsibility. It's not one data scientist acting like a hero. Model building is always a team exercise. It's also always a team project. There's a team involved in building any models. What I'm trying to do here is represent that team in form of a pyramid. So in this pyramid, I have tried to keep the various roles that I've come across in data science projects. The x-axis on this pyramid represents the strength, that is the ratio of the number of people in the team. And the y-axis represents the amount of experience required to be in that role. All roles are important. You can't do a serious data science project with even one of these roles missing. So all roles are equally important. But the strength and the experience required will be different. For example, when you start with developers, who are kind of a backbone of this entire project, developers are people who have to have skills in the required languages such as Python or R or Java or C, any other language. So these developers are supposed to build the applications, most efficient applications with most efficient and most effective application with no bugs at all. Testers, they are responsible for identifying as many bugs as possible in what the developers have done. Data architects, data engineers. Data architects and data engineers are responsible for defining the structures, defining the flow of the data sets, defining the storage systems, where data needed to be stored, how data will flow from point A to point B. Data engineers are responsible for generating additional features, how you enrich the data beyond what it is. Big data experts are all those people who are into big data technologies. They know the inside out of Hadoop file systems. That's where the data lakes has to be created. They are well versed with Spark execution engine. So these are the people who have knowledge of the ecosystem of the big data, the various tools and technologies that are put together to make the entire flow of data, storage of data possible. Of course, not all projects require modeling to be done in a big data environment. But these days, for certain reason, that is actually happening right now, knowledge of big data and cloud technology is becoming important. Junior data scientists are basically people who act as a support to the data scientist, the core data scientist. They help the data scientists, they take responsibilities of the various activities and help the data scientists in building the models. So they work very closely with the technical team and the data scientists and act like a bridge between them. But once again, not all projects need to have something called junior data scientist or associate data scientist. On the top, in the pinnacle, I have shown a senior data scientist. These are the people who are responsible for extracting useful, actionable insights from the data and convert them into models. And hopefully, the models will benefit the business in terms of top line, that is revenues, or bottom line, that is your margins, profitability. So what I'm showing here is, in this diagram is, what kind of skills is demanded? I went through various job ads on LinkedIn and various other sources where I came across opportunities for data science, various roles. What I noticed is, if for data scientist, senior data scientist roles, they're looking for people with skills in data analysis, obviously, feature engineering, model tuning, ensemble techniques, model selection. There are various other requirements. Due to shortage of space, I cannot cover this in detail in this diagram, but I'll do it subsequently in the next slide. And the kind of experience they expect is 10 plus years. In that range, it's not exactly 10 plus, it's in that range. So it's not a role which can be taken by people without any experience or very little experience. That's what is visible in the market, the way the job ads come. Junior data scientists, similar skills as senior data scientists, but the number of years of experience is slightly relaxed. I've seen 5+ years or above. The other specialists, experts in the technology, the different kind of technologies that are required, that the demand comes for. NoSQL, you have Spark, Hadoop cluster systems, then cloud-based systems. Then I also noticed, which I have not put here, TensorFlow, then Keras, all these things come over here. And generally the experience that the average experience required here is 5+. Developers and testers should be very good in what they do because they lay the foundation for the rest of the team. But the number of years of experience is 2+ years of experience. The more the experience you have in this area, the better it will be, but generally it's around 2+. Once again, all this thing which I'm sharing with you here on the screen is based on my understanding of the various job ads I've gone through. So I've summarized it over here. And for want of space, I could not put everything. So I'll cover the data scientist role in slightly more detail down the line. One big problem that I came across when I was doing this analysis is there is no standardization of these terms, the roles, and the responsibilities associated with. Unfortunately, there's no standardization. For example, some people call it data engineers, some people call it data architects. So what is a data engineer? What is a data architect? When you actually look at the job requirements, both of them seem to have similar requirements. That's why I clubbed them here, over here. Not all data science projects require all these roles. The mandatory roles are data scientists, domain experts, and customers. Customers could be internal or external, basically stakeholders. So these three roles are the key roles, but if you're working in a serious large data science projects, there are various other roles which come into play. And by the way, I have not mentioned anything about network engineers. I have not mentioned anything about database administrators. So there are various other roles which are not reflected here. The objective of this diagram was to show you the different data science specific roles that come into play, right? All right, with that discussion, the bottom line here is data science project has multiple stages, and multiple stages require different kind of experts, and data science project is always a team effort. Given that, let's look at the responsibilities I have shared. Once again, this is based on my understanding the roles which are obtained by interacting with people in these roles, my friends and my colleagues. So let me start on the top with data scientist roles. What you saw in the screen was the skills required, experience asked for in the various job ads. And what you see here is, given the role, what are the core responsibilities and others? Before I get into this, let me have a look at the questions which people have sent. There's a question from Tyagarajan. He says, does sports domain have any data science or any machine learning? Tyagarajan, sports domain is one of the important applications of data science machine learning, especially IoT-based analysis. If you want to explore this data science in sports domain, yes, there is application of data science in sports domain, and you need to, in fact, you can look for these things on the web. You'll find a lot of information on this, but more than data science, this is more of IoT-based analysis. Vijay Reddy, Python or R, which is the best for data science? Vijay Reddy, I work on both Python and R. Both of them are very handy languages, very handy tools. Prevalent is Python. Okay, R is a language designed by statisticians for statisticians. It's very powerful, but in the industry, Python rules today. I use both of them, so I leave it to you. But if you're trying to understand which one to pick up first, then I think Python will be the one to pick up first. Tyagarajan has asked again, also when you say transform data, do we use ETL tools or by using Python libraries? Tyagarajan, there is no such constraint, there is no such limitation. If using ETL tools, I can get my job done in a better and efficient way, I will go for it. So there's no such restrictions. Ashutosh Kumare, he asks, ML means only creating neural network models using data. Everything can be done by neural network. Ashutosh, correct. Deep neural network is known as universal function approximators, which means deep neural network can be used to build any kind of model. But the price you have to pay for that is deep neural networks are black box models. I cannot build my model for, say, my customer, a bank, where the customer is trying to predict, the bank wants to predict who's going to be a defaulter. So if I'm going to label somebody as a defaulter, I need to be able to explain to my stakeholders why I have labeled him as defaulter. That I will not be able to do if I use neural networks. So yes, neural network is a universal function approximator, but not always suitable. Deepak, sir, how are we going to make outliers justified, or should we neglect the Deepak? There are different ways of handling outliers. There are different ways of handling missing values. Um, Probably I'll take it up in some other session. In today's session, I'm going to keep it out of scope. But whatever you do, whatever outlier analysis, missing value analysis, whatever strategy you adopt, one thing you have to make sure is you don't end up spoiling your data. Your data is spoiled when that data does not represent the world outside in which your model is going to reside. So if you do anything to your data, outlier fixing or missing value analysis, which ends up modifying the data in such a way that it is no more similar to the universe from which you brought the data, then you have lost it. So I'll probably take this up in some other session, some other time. Deepak has asked a question, how these clusters of cars are figured out. Deepak, I mean, how can we categorize these given data sets in 3 clusters? Deepak, for this, you need to understand a unsupervised learning method called k-means clustering, which automatically is able to identify these 3 distinct clusters. Of course, interpreting the clusters is still manual. I have to sit down and understand what this cluster is, I have to give the meaning to the cluster, like what we did by looking at the box plots. Then Akshay is asking, sir, which are the best countries for data science, jobs, and education? Akshay, in the current environment, you know what's going on around. I think the best place for us right now to be is India. Nirmal Kumar Malik, how to gain knowledge on data science programming? Nirmal, I'll share this with you down the line. We'll see that. Okay, I need to still answer Alex's question. We are almost there, Alex. Just hang on for a minute. Alex, Giant, and Samarendra, we need to answer that. All right. So let's move on. I have one more set of questions. Komal has asked, so sir, is it needed to have 5 years of experience to become a senior data scientist? Komal, the more experience you have in this area of data science, the easier it will be for you to get into the role of a senior data scientist. Yeah, it becomes a challenge when you apply for, say, these roles, but without the relevant number of years behind you. Data scientist job is a very high pressure job. It's a very responsible job. You need to have a lot of expertise to be in this job. If you have it, if you're able to demonstrate it, even with 2 years of experience, you'll be in. Actually, I'm working as a data analyst and I want to be in data science career. So can I? Of course you can. Komal, of course you can. Ahmed asked, sir, how to get experience? Because companies want experience, but does not provide opportunities. Ahmed, I'm going to answer this question in the almost end of the presentation. I have already shared one URL with you. I'll share some more information with you. Then I think it will help you understand how you can gain that experience. I've been on interview panels. I've interviewed many people. What we look for as interviewers from the candidates is demonstrable experience. I'm not convinced if somebody comes and says, I know data science, I know machine learning, I have worked on these projects. If that person shows me using a Git account, look, these are the projects I've done, these are the problems I've faced, and this is how I resolved. If he is able to demonstrate to me, then I'm more convinced. So Ahmed, I'll again answer this question in a different way down the line. Soumya has asked a question, how to get live experience? I think this is related to the previous question. Meghala has asked, sir, how many percentage of chance is there to get a job as data analyst for freshers? Meghala, right now, the current situation that we are in, I'm seeing a lot of opportunities for interns, freshers, a lot of opportunities coming for interns and freshers. So that way, if you just started the journey, you're just entering the professional life, I think you are at an advantage. Anyway, coming down to this slide, what I've done here is the roles, different data science roles, core responsibilities. I'll quickly run through them for want of time. Data scientists, they're responsible, core responsibility. They are responsible for extracting the actionable insights, building models from them, and addressing the business problems. You get into this role, but you don't know how to start, what to do. You don't know. You're not able to churn out results. You're not able to deliver the results. You're not able to deliver the meet the expectation of the stakeholders. Then you're in trouble. So that's why this role is a high pressure job. It's a very enjoyable job. It's a very creative job. But you need to have all the skills and experience with you to be able to enjoy this job. The other responsibilities that we carry out in data science as a data scientist is lead a team of data scientists. We groom other people into this role. We act as a bridge between the team and the customers. Estimate, we have to be good in project planning. Given the problem statement, I need to sit down and estimate, just like you estimate for any other conventional software project. You need to be good in risk management. What are the different kind of risks I see in this project, given the data set and given the expectation? How do you mitigate the risk? All the skills come into play here. A lot of soft skills are required. A lot of people think that data scientist job is something like you put a white coat, sit in a corner with a laptop and keep doing something. No, not at all. Data scientist role is a multifaceted role. You need to have various skills, including soft skills, your ability to negotiate, your ability to communicate, make presentations. All these things play a very important role. Junior data scientist, similar as senior data scientist, everything is similar. They engage in the other way. They talk to the technical team and data scientists. They become a bridge between them. But otherwise, most of the activities they do remain same. Data architects, they maintain the database in appropriate formats, structures. These days, we have big data with us. We have NoSQL storage systems with us. We have RDBMS with us. They are responsible to decide when a data comes into the system, what format, what structure, and how do you connect all these things. That is their responsibility. They need to collaborate with the data scientist in designing these database solutions, prepare alternate designs, keep migrating data from one, maybe NoSQL to RDBMS, RDBMS to NoSQL, using Scoop or whatever. So they need to be experts in this area. Data engineers, they're the ones who transform the data from the state it is in to the state it's required to be in, of course, in collaboration with the data scientists again. They analyze the data, they do the trend analysis, they do all these things and communicate those findings with the key stakeholders, including data scientists. Big data solution architects, I've already spoken about this. They're responsible for managing the full life cycle of the Hadoop-based solutions. But once again, I repeat, since I come from this environment, and I have seen projects, data science projects being done in this environment, that's what I'm sharing with you. But not all data science projects need Hadoop systems or big data systems. Developers, we have already seen this, and testers, again, we have already seen this. The additional responsibilities are similar to what they have in the conventional IT projects. So these are some of the roles and responsibilities that you will have to understand and get into when you look at these roles. Can I become a data scientist? As some of you have asked now, can I become a data scientist? Of course you can, why not? You can become a data scientist, but please understand the roles and responsibilities that the data scientist role carries with it, and prepare for those. Prepare for getting into that role. Don't directly jump into that role. I have seen cases where somehow people clicked and jumped into the role of data scientist, and then I get a call, Professor, this is what the requirement is. Can you tell me how to start? That's not the situation to be in as a data scientist. One of the best ways of finding out what these roles are is to go on the web and search for, just give this search, a day in life of. If you want to know about data scientists, look for data scientists. Many of these data scientists have shared their experience, they're practitioners. So they share with you what they do in the role day to day. If you want to look for data architect, data engineers, just look for a day in life of. So when you go through these videos and these various sites, websites, it gives you a first-hand information of what is it that you'll be doing, most likely to be doing in these roles. And it will also help you understand what kind of skills you need to acquire and how to prepare for this. What is the expectation from you, by the stakeholder expectations from you when you get into these roles. So please spend some time and do search for day in life of, this is a very good rich source of information about these rules. Since many of the people I've interacted with, they wanted to become data scientists. You can become a data scientist. Why you cannot become a data scientist? You can. But please understand the key responsibilities that data scientists carry on their heads, on their shoulders. We have already discussed this. It's kind of a repeat of what I've already done. Given the problem statements, identify the source, the kind of data you need. Where will you get the data from? How do you get the data into your systems? You may have to engage with the various technical experts to put all those systems in place to get the data into your system, get the data streaming into your system. You might have to buy the data from the source. So all these things will come into here. And this is where you'll collaborate with the data architects, the Hadoop engineers, the programmers, the developers, and all these things. Establish reliability of data given the data. Many people, even some of the practicing data scientists, unfortunately do this mistake where they take the data at its face value. Suppose you're working on that business requirement where the management has asked to build using data science, can you help us improve our CSAT, customer satisfaction rating for tech support, by say 3 points, 3 percentage points or 3 points. Right now, the rating is somewhere around 4.8. Can you help us improve by say 3 points to 4.9? What would you do? You'll obviously look for some kind of a historic archived data set. Where will you get it from? You obviously will get the data from the tech support team. Now, when the tech support team shares the data with you, is it not probable, it's not highly probable that the data that share with you are all those cases where they got very high customer CSAT ratings and they hide the data sets, data points where their performance was not so good? It's a natural human tendency. You didn't know that. You went and started working on this data set where the data set is just, it's a biased data set. It reflects only those cases where they got very good ratings. So the model that you build on this is definitely not going to achieve the business objectives. So whether the data is coming from within or outside, we have to establish the reliability of the data set. Reliability means, does this data reflect the reality on the ground? Once you establish that, then we use exploratory data analytics. We use various techniques such as unsupervised learning method clustering techniques to understand the story of the data. What is the data telling us? That is called story of the data. We use descriptive statistics. We use clustering methodologies. We use various other techniques available to us to understand what the data is telling us, including the hidden information, everything. Once we have done this, we also do what is called technically called feature selection. Of all the given data set, is everything equally important? Do I need everything that is given to me to build models? Or is there something that I can leave out, build the models using the rest? This is where we do feature selection. That is, we select things which are important to us, which we think is useful to us, and ignore things which are not. Transform the data, a lot of missing values, a lot of outliers. They are at different scales. Each attribute is in different scales, different units of measurement, so on and so forth. Then we might transform the data into a state where we think it's good enough to go ahead and build the models on. Identify and mitigate the risk. Sometimes the problem statement given to us is such that the expectation cannot be met given the quality of the data we have on hand, and there is no other choice. In such case, as a data scientist, it is my responsibility to identify the risks, communicate the risks to the stakeholders, and do whatever I can do to mitigate those risk of failures of these models in production. Like any project, you have to plan this project also, you have to do your estimates. Then you also have to establish a way of demonstrating the accuracy of the model, how the model is going to perform in production. You have to be able to estimate what performance you're likely to get in production. We call it 95% confidence level. report the project progress to the stakeholders, weekly status reports, all those things happen here also. As a data scientist, you're responsible to extract every inch, every small percentage of performance you can extract out of the model without making the model overfit, without preventing the model from generalizing in production. So we have to extract as much performance as we can without making the model irrelevant in production. That is what we call generalizability. There are various other soft skills that come into play. We have to groom the junior data scientists. We have to present our findings to the key stakeholders. All the things come into play here also. And of course, we spend a lot of time in evaluating the new technologies, the new algorithms that come on the horizon. We do all these things. So kindly go through that a day in life of a data scientist to get a good feel of what these people, data scientists, do in their day-to-day activity. So the key characteristics of a data scientist, the common characteristics that you'll observe is you should have a very strong flair for data analysis. You should love data. You'll be surrounded by data. You'll be talking data. You'll be analyzing data most of the time. So you'll be diving into the data sets to understand. You'll be combining data sets. You'll be doing everything with data. In conventional IT world, where it starts with business requirement, it goes to technical requirements. Technical requirements turns into design requirements, turns into code. And once your code has acquired some shape, then you probably will do some unit testing. And after unit testing, you'll do integration testing, and acceptance testing comes in the last. So the role that the data has to play in conventional IT is not as significant. It's not as significant as it is in data science projects. The data science project will start with data, will end with data. If you're not a person who loves data sets, you're not a person of that type, then I think you should think twice before you get into this role. Of course, you have to have programming skills. Programming skills today in Python is in demand, but there are other languages also which are playing very key role. Java, C, Ruby, Go is picking up popularity. TensorFlow, Keras, PyTorch. There are various options in which you can make use of in building your models. But Python, TensorFlow, Keras, PyTorch, these are the ones which are right now kind of most prevalent in the industry. Experience in platforms such as big data platforms, not a must, but it's a positive point. And if you have knowledge of distributed engines, execution engines such as Spark, it will definitely be a plus point. Because scalability of the model in production often becomes a huge challenge. So that's where Spark comes in. Knowledge about the various libraries and packages that you can make use of in building your models, the libraries that are available in Python, the libraries that are available in TensorFlow, you're expected to have all these things. These people will be thorough in all these things. Presentation skills, data visualization tools, usage of data visualization tools such as your Tableau. These people are, again, experts in at least one or two of these tools. Of course, project planning, team building, negotiation skills, the soft skills play a very important role too. So what I'm trying to do here is, to all those people who aspire to become data scientists, you can. You already know what the expectations are, what they do. If you can scale up yourselves into these responsibilities, to cover these responsibilities, why not? You can become a data scientist. Who's stopping you? So in this section, I'm going to talk about what are the different strategies you can adopt to get into the data science world, to get into the different data science goals that are available. So I'm going to discuss the strategy with you, but before I do that, I have another set of questions which I'd like to take. Samuel has asked a question. The number of years of experience is overall or relevant? Samuel, this is a relevant experience. Since data science is recently picked up one, for example, I'm 15 years plus experience, but now new to AML, how do you sell me? Okay, Samuel, I'm going to answer your question in an indirect way very soon. But As I said, data science is not really a new field. What we used to do in market research so many years ago is exactly what we are doing now with larger data set with much better technologies. So if you look at me, I have more than 10 years of experience already, even though the data science itself may not be such a, I mean, it may not be a field of that duration. So Samuel, I'll answer this question in an indirect way. Just hold on for a minute. Saurabh has asked a question. What would be the future of data science? Would there be AI solutions for analyzing data in future? Sam, Saurabh, this discussion has been going on where people have been talking about AI replacing data scientists to do all this analysis, but I think I will take it with a pinch of salt. So as far as I can see, the role of data scientists is going to continue to be very important, not only the role of data scientists, but all the other supporting roles as well. Vijay Kumar, sir, can you please say about the average salary of AI/ML engineers in India? Vijay Kumar, all I can say is the salary will be decent salaries, provided you get into a really good data science environment. I've seen some cases where even what do you call them, interns in data science are getting a very decent package. Okay, so but I will not be able to specifically tell you. All I can say is AI/ML engineers, they get decent breaks. Okay, but please keep in mind, when you get into these roles, these are highly responsible roles like any other conventional IT roles. So if you're able to perform, you're able to demonstrate, then there is no stopping. Priya, I'm working in BI with 10 years experience. Can I get into data science? Priya, of course you can. Data science role as a senior. Priya, of course you can. Just hold on, Priya. Just we'll take this question, especially this one, in the next few slides. Vishnu Prasad, how do an already experienced IT professional choose data science roles? I'm 11 years old experience and entering the data science domain. Vishnu, once again, I'm just there. The strategy will help you understand that. Hajija has asked, what can a mechanical engineer learn of? Hajija, mechanical engineering, data science, they come kind of naturally together. Okay, so you can definitely get into data science, machine learning. I know cases where they do, instead of doing preventive maintenance, they do predictive maintenance. When is a system likely to go down? They don't do preventive maintenance, they do predictive maintenance. So the model predicts when a system is likely to go down, given the various parameters of that particular system that the model has taken in. So a lot of application of data science machine learning in mechanical manufacturing units, where it is being used for predictive maintenance. Tathagata, I believe this is Tathagat. Sir, what is your view for people looking for transition keen on data science, having PGP, BABI accreditation, 25 years of experience in different industries? Okay, a lot of people are asking me questions which are similar in nature. So I think I should get into the strategies. Pawan Reddy, which learning path do you suggest for data analyst career? Okay, Pawan Reddy, again, just hold on. The number of years experience, sort of, okay, Samuel has asked a question. The number of years of experiences overall, or, oh, sorry, I have already answered this question. Saurabh, what should be the future? Okay, I have already answered this question. So many of the questions which I have parked right now will be answered in this section, which I'm going to take. Now, given that you aspire to get into data science, so what should be your strategy be? How should you approach all these various roles? The most important thing that you should do, now that I have discussed the various roles that come into play in data science, it's not just the data scientist. So given those various roles that have come into play, you have to identify the low-hanging fruits for yourselves. From your point of view, low-hanging fruits will be those roles which are very similar to the roles you are already in, which require the same kind of skills or experience that you already have. Maybe with a minor delta effort, you'll be able to fine-tune your skills to get into those roles. So identify the low-hanging fruits in the data science roles. acquire the delta skills required to get into those roles. So list the skills required by that role and the roles that you have, identify the gap between what is required and what you have. These gaps you need to fill up by undergoing training, for which you can explore the various online facilities available to fill up these gaps quickly and get into those roles. Once you get into those low-hanging fruits or the roles, once you get into those roles, you can always scale up into that organization and go up the pyramid and get into the data scientist role, at least the associate data scientist role. So that is the strategy which I would advise to all of you, especially to those who already have some experience with them, some work experience with them. I would not advise anybody to drop their significant work experience that they have with them and start afresh, because that will be slightly risky in the current context. If it was normal context, say 6 months ago, probably that risk would have been worth it. But in current context, that risk is not worth it. So what I would advise is look for the low-hanging fruits and go into those roles and scale up over a period of time. It won't happen in a day or two. You have to scale up over a period of time. And to bridge the gap in the skills that you have, you may want to make use of online resources. Many people ask me, especially on LinkedIn, I get a lot of messages. Sir, can we get into data science? Can we do data science? What I tell them is, please go and explore what data science is by looking at these various online courses available. If you think it is your cup of tea, if you think you're going to enjoy, one of the key things is you have to enjoy to work with data sets. If you think it's going to be your cup of tea, why not get into this and get some serious trainings on this and get into those roles. What is important is objective demonstration of the skills. This point number 5 is for those youngsters who are at the very beginning of the career. Now, you don't have experience with you, but the job ads that you come across, they ask for experience. Okay, so how do you apply for those jobs? That is where I said skills on resume is okay, but you should be able to demonstrate those skills. And the demonstratability, for example, can be brought in by using a Git account where you store all the projects that you've done, share your experience through those projects with the interviewers, blog, and you can do various other activities to demonstrate, yes, boss, I know this. And people who really know what they're talking about will find it very easy to do all these things, to demonstrate it. Yeah? Register with various data science groups that are available on LinkedIn. On LinkedIn, there are so many machine learning groups, so many data science groups. Register, become a member of those groups, participate in their activities, follow those people who are practitioners, build your networks. But please don't spam, don't start sending your resumes, flood their mailboxes with your resumes. So people who are in the beginning of the career, I would advise you to first register yourself in various groups, build your networks, and start doing projects and store those projects in a GitHub repository and use that as an evidence to demonstrate your skills. Yeah, those people who have certain experience with them, my request to them would be, again, the strategy for you people is the low-hanging fruits and the minimal skill gap, cover that skill gap, get into those roles and scale up into the data scientist role. What I've done here is, in fact, I'll take some more questions. Thank you. Raj has asked the question, which language is best for manipulating data and data science? Raj, I make use of Python and R. I love both the languages. So, but there's no particular language which is prevailing for manipulating data in data science. I honestly don't know what you mean by manipulating. I presume you mean by data cleansing. Chandar has asked a question, sir, in phone itself, we can make a career on Python programming. Sir, in phone itself, we can make a career in Python programming. Chandar, I don't know what it means, but can you make a career in Python programming? Of course. I don't know what is your experience level, what are you beginning of a career? I don't know. But usually the developers that I talked about in the pyramid, They're people who are experts in Python programming, right? So of course you can make career in Python programming. Ashutosh, he's asked, if someone knows Python and some other languages but doesn't know Java, is it okay? No, it's not a loss, not at all. It's absolutely fine. You know Python, you're expert in Python, then having knowledge of Java is an additional plus. But not having knowledge of Java is not going to come your way. Because if you go and see on, say, Kaggle.com, Kaggle, Kaggle.com, go and see those projects which are submitted over there by various practicing data scientists. Most of the projects will be in Python, and the next one will be R. Very few will be in Java, very few in C. So to answer your question, Ashutosh, it's not a loss. Akshay Power, which is the most highest paid and most demanding job in coming 5-6 years? Ashutosh, Akshay, if only I could see into the future. Honestly, given the current situation we are in, whatever is happening around us, you know what's happening around us. I really can't look beyond even 1 month or 2 months, right? Had it been a normal stuff, normal day-to-day, and where we were 4 or 5 months ago, then probably I could have answered this question. Which is the most highest paid, most demanding job? But it's no use of answering this question in the current context, in the current environment. So I'm going to leave it at that. Ahmed has asked a question: what to learn after Pandas, NumPy for data science? Ahmed, it's an ocean. There's so much to learn. My sincere advice to you would be, I'm not sure, the information is insufficient for me. So my advice to you would be, please pick up TensorFlow, Keras. These two combinations, yeah? These are becoming kind of industry standard. Code with Karthik. What is the roadmap for data science? Karthik, this is what I'm trying to give through this presentation. How do you get into the data science role? We are almost there. Ananda has asked, I am from commerce background with zero knowledge of programming. Do you think students like me will exist in data science? Anand, it's all, there's no reason why you can't get into data science. I'm a commerce graduate, I'm an MBA. I'm not an engineer, I'm not a science graduate either, okay? So it's all how you prepare yourself for this role, how much effort you put into this. Nobody is going to stop you from getting into this just because you are a commerce graduate. You can pick up programming and you can get into all these things, but it's your call. You have to put effort in. Vishwanath has asked a question: what is the scope of data science for freelance web developers? Vishwanath, the answer to this question is very generic. The scope for data science is large, but freelancers, I really don't understand, because I was a freelancer when I was in big data. The problem which I faced is customers would not like to share their data with anybody who's not part of the organization. So I think that will answer the question. I'll take just a few more and then I'll get into this. Deepak has asked a question. Sir, with more than 10 years experience in teaching, can I get better opportunity in data science job? Definitely, Deepak. I do trainings in data science, machine learning. Of course, I have a lot of experience behind me in market research and all, which I carry forward into this. So if you can pick up data science, if you can understand the concepts sufficiently well, so that you can put it across to people who want to learn data science, why not? You can definitely explore this option. Sunny has asked a question: will there be more QA testers role in data science? Sunny, this is a QA roles is like a perennial role. Whether data science or Hadoop, whatever it is, you need QA everywhere. So of course you will need, and in fact, I have already listed out here in the grid. Look at the grid. People who are in traditional QA testing roles, they can naturally get into Hadoop testers, roles for Hadoop testers, but you will have to pick up some technology related to Hadoop, for example. You need to pick up those technologies. Yeah. Otherwise, if you're already doing testing on one particular language, such as your Java or C, or if you're doing all those things, then you can carry forward that skills here also. All right, so let me get into this grid. These are the conventional roles that I'm aware of, that I came across in my terms when I was in IT, conventional IT. And these are the roles that I've come across both in big data and data science put together. If you are a data analyst, as one of you have asked here a question, if you're a data analyst, you are already working data, some kind of data sets and data analysis you're already drawing, then the natural fit will be a data scientist role. Preferably, the fit will be the junior data scientist role or data engineer, data architect. So as a data analyst in conventional environment, you can definitely look for a junior data scientist and this, but you can't simply jump into it. You need to acquire certain skills. There will be a skill gap. You need to fill up those skill gaps. And this, I think, will be a natural fit for you. If you're a business analyst, then you can again look at business analysts is again people who deal with data related to the business. They do projections, they do presentations, they do all these things, present the findings. They can also look at these roles, but once again, there will be a gap in the skills. They need to acquire those skills. If you're a system architect, then the natural fit, the low-hanging fruit for you would be data architect or big data architect, those kind of roles. If you're a database administrator, then obviously Hadoop administration will be a low-hanging fruit for you. And again, you can also look at the data architect, data engineer roles also, if you wish to. If you're a pre-sales consultant guy, then we need a lot of pre-sale consultant in data science world also. So you can naturally fit into that. You need to widen your horizons. You need to understand what big data environment is, what this data science is all about, what are the tools, at least at a very surface level, you need to be aware of these things. Developers naturally fit into Hadoop developer environment. There is a lot of need for developers. Testers, as I said, it's a perennial role. Developer and testers are required all over the place. You may have to learn a new language. You may have to learn a new testing tool. So if you learn all these things, opportunities will open up in this area, in the data science field also for you. All those other combinations which are grayed out. For example, if you're a pre-sale consultant and you want to become a data scientist, then that will be the most difficult journey for you. You can achieve it, you can do it, why not? I never say no that you can't do it, you can do it, but it will not be a low-hanging fruit for you. So a lot of effort, a lot of time, a lot of energy will be required to get into those roles. Similarly, if a database administrator wants to become, say, a data scientist, once again, it's not a natural fit. So that means you'll have to invest that much more time, effort, energy to get into those roles. So once again, I repeat, the way to get into these data science roles will be, from your point of view, look at the roles which are the low-hanging fruits for you, prepare for those roles. Get into those roles, get into a data science project team, and then scale up on the job. Learn the skills, learn the tricks of the trade on the job, and scale up and get into those higher roles if you wish to. And once you get into this role, when you're preparing to get into these roles, practice, practice, practice. There are a lot of open source data sets. I've already shared one link with you. You can also look at this data sets research google.com. It's a facility given by Google where you can fire a query. I'm looking for this specific kind of data set. It'll search across the web and give you the sources where you have that data set available. Push your horizons. In this field, you have to be continuously on your toes. If you're a person who does not like to go back to books, if you're a person who does not like to pick up new skills, pick up new knowledge, I'm sorry to say, then this will be a very difficult field for you to be in. You have to continuously keep reading. You have to continuously upgrade yourself with different skills that come on the horizons. You have to keep yourself abreast with the latest. There are various books available, various online articles, online web locations available where you can go and learn these things. I've listed out some of them which I have. For example, I own these books. I have these books with me. I have a Kindle app with me. I download all the books. Some of these books are available as PDF. And whenever time permits, if I'm in a flight from, say, Bangalore to Delhi, I spend my time reading those books, reading the articles that I come across on the web. In short, you have to be on your toes. There's no point in time when you could say, okay, I read enough. I don't need to read anymore. That will never happen. That will never come. And when you download the data sets, one piece of advice, caution, especially on Kaggle, not all data sets are open source. Please be careful. Sometimes on Kaggle, some data sets are available to us only when we participate in the competitions. If you're not participating in the competitions, we are not supposed to use the data set for any other purpose. So be careful when you download the data sets and use it. Impact of the corona on data science. This situation that we are in is such an uncomfortable situation for all of us. It has impacted everybody, including data science. So now I would like to spend some time with you on what impact did it have on data science. So before I get into that, again, I would like to take the questions which have sparked and some new questions here. Thank you. How do an already experienced IT professional choose data science role? Vishnu, I think I have answered the question. What are the mechanical, okay, this is Hajeja asking the same question. Okay, I've already answered this question again. Tathagat, what in your view are people looking for transition keen or data science? Tathagat, I think I have answered this question also. Pawan Reddy, which learning path do you suggest for data analyst career? Pawan, I think I have answered your question as well. Then we have Arvind, does Python require knowledge in Java? Arvind, no. Python is a language. If you master this language, you don't need to know Java, but knowing Java will always be an additional plus. Hari Krishna, sir, I have 4 years in Java, full stack developer, JetKing. Shall I apply? Of course, Hari Krishna. A lot of things that are developed in Hadoop, a lot of packages that are written in Hadoop and for data science, they are developed in C and Java. So of course you can, Hari. All right. So with this, Alex, your question was pending. Wondering how can I start data science and ML? Alex, I think I have answered your question. Jayant, what prerequisites for data science? I think I have answered your question as well. When should we apply Python or C++? Samarendra, this is all requirement specific. I make use of R and Python from the very beginning of the project till end of the project. Now let me just cover this one last part of this. What I'm observing is the need for data science and analytics has become even more important. That's a good thing. Every entity, every business entity is impacted because of this corona. So all of them are looking for a quick recovery from the state they are in. They all want to quickly go back to the normal with minimal investment, and they want maximum returns. They are not in a position to take any more risks. For example, if I'm in a retail, I want to quickly open up the business and attract customers, then I need to know who are the customers who are likely to come to me quickly, right? All the customer behavior has changed. So now I need to redo the modeling. So if you're in understanding customer behavior, you're doing product pricing, promotion strategies, you're handling, redoing your supply chain, whatever you're doing, everywhere, there's a very urgent need for analytics that has come up. Many of the models built before April 2020 BC, that is before Corona, as I said, they will have to be recalibrated, redone, they'll have to be relooked into. But I have also seen something else happening because of the cost control, because of the loss that they have incurred, they're very cost conscious. And because of that, what is happening is a person has to wear many hats. You can be a data scientist, but you also have to play the role of a data architect. You also have to play the role of a data engineer, everything. You also have to write your own code. So a person has to wear many hats. And a lot of organizations have already frozen on the intakes. You would have heard about Google freezing the intakes a month ago. A lot of furloughs, a lot of layoffs. Unfortunate thing, this is happening. But the bright side is for freshers who are coming out of college with 0 or 2 years of experience, I'm seeing a lot of opportunities for them opening up as interns. So in case you people are in that stage of your career, I think you should look up to it. Please kindly prepare yourselves. When we go to the new normal, when the opportunities crop up, the worst thing that can happen is you're not ready to take on those opportunities. So please prepare yourselves. Those with experience, with behind them, I already said my strategy would be the low-hanging fruits and prepare again for the opportunities. If you have exposure to cloud environment, it'll be great. As you would have yourself seen, those organizations which are not on cloud, they suffered the most during the lockdown, whereas those people who had already got some systems on the cloud, some kind of a presence on the cloud, they could work from home. So working from home, working online, cloud-based systems is going to become the part of the new norm. And most of these data science projects will also, you'll often see is happening on these kind of environments. Natural language processing is already very important and is going to become even more important, because now online we are going to exchange a lot of information through various social media and all these things, which is the thing that NLP thrives on. So NLP is going to play a very significant, important role down the line. That's what I'm seeing happening. So given all this discussion, in the context of all these points which I've shared with you, my observation is, my advice to people who ask me these questions is, prepare strategically for multiple roles. Don't target one particular role. Look at multiple roles as low-hanging fruits, of course, which you think you can get into. This is the right time for you to enrich your skills, to increase your skill portfolio. Given the roles that you're targeting, given the skill gap, please go ahead and fill those skills as quickly as you can. Build and nourish a professional network. It's very important to network. A lot of opportunities come through networks. When I say networks, I don't mean network of friends. I mean network of professionals, such as on platforms like LI, LinkedIn. Attend data science conferences and webinars. There are a lot of data science conferences scheduled in September. Please go and Google for it, web search for it, you'll find them. I didn't put them here for the fear of somebody might say that I'm promoting certain names. I don't want to do that. So a lot of conferences are coming up in September in Bangalore, India. Go and attend those conferences, build your networks. Make your presence felt. Nobody is going to come and pick you up. You have to market yourself. So please blog about your things, write articles on what you've done, so on and so forth. Share yourself in those groups which I asked you to become members of. And the need of the hour right now, the way things are panning out, we need to be patient. We need to be slightly kind of, we have no control over what's happening. So we need to be slightly patient. We can't rush through things. We can't rush for things. Be proactive. Let not the situation prevailing weigh you down. Be proactive. Go ahead and do all those things that you need to do to get into these roles that I discussed with you. Don't wait for things to happen. Right? So, wish you all a very grand success ahead. I hope I was able to answer all your questions that you asked. If you have further any more questions, feel free to write to the organizers of this event. They'll pass it on to me and I'll respond. With that, thank you very much for your time. Have a nice day.